A revolution in the design of buildings with shifted floors, such as buildings with staircases, production halls with an adjoining office area, or single-family homes with a lowered living room level, brings the possibility of creating additional and internal story levels. During the design process on plan views, both the main, additional and internal story levels are visible in the worksheet selection window in the form of a tree. Each element, except for riser and building contour elements, can be assigned to the main, additional, or internal story level in the data table window. To facilitate orientation on the level currently being designed, rooms located on story levels other than the currently selected one have a corresponding graphical marker. The new guideline feature allows for the preliminary indication of the division line of structural elements, such as floors, activating additional snap points. The division of structural elements function allows for the division of walls, floors, roofs, and manual rooms along the designated cutting line. Structural elements like walls can define their position from level to level according to previously defined levels. The Correct Wall Connections button corrects wall connections if they were not correctly joined during their creation or modification. In 3D view, it is possible to display story levels and their elevations according to the data defined in the Story Management window. A slab element can close spaces with its side wall, allowing for the automatic creation of rooms. This enables the creation of stairs or cascading floor slabs that define the complex shape of the space and its thermal partitions. Designing on a selected level determines the assignment of inserted installation elements to the appropriate level and the automatic connection of receivers to the installation. The automatic generation of schematic views function also considers additional and internal story levels. Due to its prototype nature for such cases, the new entry in the element data table starting point is described with the prefix beta. When copying an entire story using the Copy button in the Story Management window, additional and internal story levels of the base story are also copied along with the assigned installation elements. Similarly, functions for copying selected installation fragments on floors above or below, consider the presence of additional and internal story levels on other stories and their elevations. In the case where the building structure is created from an IFC file, the new button "Create an additional story level between selected slabs roofs" from IFC file allows for the automatic creation of additional story levels, after selecting the appropriate horizontal structural partitions from the IFC file. A new icon placed between the copy and paste buttons allows for individual or group copying of construction and installation elements with the prior specification of a base point, for example, the intersection point of two lines on the underlay, end of the pipe run, or corner of a room. It is possible to copy selected construction and installation elements to other stories. It is also possible to copy selected construction and installation elements between different projects. In this case, it is necessary to open the same editing scope in both files. After selecting elements in the project, invoking the copy command, and then paste, a new window appears allowing for copying with mirroring or rotation by a specified angle. During the operation, it is possible to specify the angle of the mirror axis and the direction of horizontal or vertical mirror reflection. The mirror reflection and rotation function also works with the copy with base point function. All mentioned functions also allow for similarly copying installation elements. It is possible to rotate and mirror copy radiators, receivers, distribution network, or radiant installations along with the pipe feed routes. The program ensures the correct direction of the reflection of installation elements, for example, radiators. In the case of projects with multi-story risers, after copying the installation, it is necessary to verify and possibly correct the connections of pipe runs to risers. program has been equipped with a new search criterion allowing for easy identification of internal, external, and mixed walls in the created building structure. The identification of the wall type takes place during the calculation stage of the building structure. This allows walls of the selected type to be easily found in the building model and distinguished from the rest with a dedicated style or collectively change their data, greatly facilitating the management of the designed building structure, especially in large and architecturally complex objects. After selecting the new option in the General Data window, linear thermal bridges at the junction of structural partitions are automatically recognized based on the created thermal model of the building. To account for linear thermal bridges in calculations, the default variant must be specified for each type of linear thermal bridge. Based on this, a linear heat transfer coefficient compliant with the standard is adopted. The new dedicated editing scope allows for a convenient and detailed analysis of detected linear thermal bridges and the modification of data individually or collectively for selected linear thermal bridges. The user has various tools available to verify the correctness of the created model of linear thermal bridges and their impact on the results of the calculated design heat load. For example, the new tree building, thermal bridges view, in the project browser window allows for a detailed analysis of thermal bridges identified in each room. Using additional icons next to each definition of a thermal bridge, one can quickly and accurately check the occurrence of a particular thermal bridge in the thermal model. A complement to the new functionality of automatic detection of linear thermal bridges is also the possibility of considering point thermal bridges in calculations. Based on data about the type of point thermal bridges, indicating the definition of thermal partitions in which they occur, and specifying their quantity directly on the partition or per square meter of the thermal partition area, the program determines so-called point thermal bridges areas in the thermal model. After placing the mouse cursor on a specific area, information about the number of point thermal bridges affecting that thermal partition can be read. After selecting the point thermal bridges area, its data can also be adjusted. Selecting the point thermal bridges area in the 2D or 3D window also highlights the corresponding cell in the room partition table, making it easy to verify their impact on the resulting heat transfer coefficient of the partition. In the project browser window, in the building partition view tree, for thermal partitions without an assigned definition, an additional graphical symbol is displayed. This allows for an even faster analysis and verification of the correctness of assigning definitions to partitions and finding them in the thermal model of the building. In the project browser window, in the partition definitions tree, the ability to assign definitions to partitions previously selected in the building's thermal model with single button has been added. Group selection of partitions is possible both in the 2D and 3D window using buttons that allow you to select partitions from the indicated area or all partitions of a given type in the project. The new Big Division and Expansion Joint button groups all functions that can be used to divide heating and cooling surfaces and insert an expansion joint. Small icons have been replaced with larger and more legible ones. Additionally, under each function there is a detailed description of its operation. There is also a new expansion joint manual icon, which allows you to insert an expansion joint of any length on the indicated edge of the heating and cooling zone. The graphic elements structure cross-section drawing, manifold table and mixer control unit chart are now located in the labels and graphics gallery. The button for manually drawing heating and cooling loops has also been replaced with a larger one, making it easier to find. For junctions attaching two or more pipe runs to a stack that are not visualized due to incorrectly selected or overlapping fittings, the context operation is available. Split the junction on the basis of sized main fittings. Once the connections have been checked, this will split the junction into two, separated vertically. By using the function automatically connect terminal units for the simultaneously selected air admittance valve and a drainage pipe run running within 1 meter distance, on the plan view, an automatic connection of the elements with the vent pipe run is created. In the data of the story where the network of waste manifold will be drawn, the distance of this network from the lower or upper slab must be determined. Instead of a single number, a clearer selection list has been introduced, aided in 2 cases by the setting of distances, adapted to different design situations, usable or not usable basements, buildings without basement, etc. The gravity rainwater drainage module is enabled by a separate checkbox in the General Data window. After switching on the module, General Data dedicated to it, pipe sizing options, component styles and a new editing scope in the 2D editor and 3D view are displayed. The button that starts the calculations is common with the gravity sanitary drainage module. In the currently published version, you can create a complete installation model, perform its calculations, obtain a bill of materials and printouts of plan views. For the next release, work is underway to supplement the module with automatic schematic views, export of drawings and complete tabular printouts. In the data of the starting point element, it is possible to declare the maximum length of the hidden pipe run connecting the riser with the first T behind the riser. This allows for the schematic views directly to the left and right of the riser without disconnecting the installation. The hidden pipe run is symbolically drawn as a slanted segment near the riser.